Hi, everyone. Welcome back. Could I ask everyone to sit back down, please, so we can start our next session and get closer as well. It would be nicer instead of everyone being right at the bar. Yeah, even closer. Awesome. So, first question, how are we feeling? Woo! Yes, yay, awesome. Are you enjoying the food, enjoying the drinks, the coffee? Yeah? Yes, dogs. Nice, nice. I've had some really awesome. This one. Yeah. Don't tell them. Yeah, I've had some really awesome conversations. So thank you so much to everyone for keeping the energy up. So our next talk is by Beyang, and I'm so excited about this one. We're gonna have a live demo as well, if it all works. So yeah, bear with us on that. Okay, without further ado, Beyang.
Great. Thank you so much. It's great to see everyone. Thank you, Gitpod, for hosting this awesome conference. My name is Beyang. I'm the CTO, co-founder of a company called Sourcegraph. Today, I'm here to talk about Cody. Cody is an open source AI coding assistant that we built, and here to talk about what that is, how Cody works, and share some of the technical challenges that we're kind of in the process of overcoming as we build and work with large language models. And feel free to interrupt. Actually, want to make this as interactive as possible. If you want to like ask a question or if there's anything that's confusing you, just raise your hand and we'll try to make this interactive. Okay, so before I get into what Cody is, I want to take a step back and talk about the problem that we're trying to solve at Sourcegraph. So when we first started working on our tool and our company now more than 10 years ago, it started with this recognition for us, which was that the vast majority of our job as software engineers was not so much about sitting down and writing the code. It was more about understanding all the code that kind of already exists in the world. Understanding open source, seeing what sort of libraries and packages are out there and available for use, understanding the code inside my private code base I'm integrating new functionality into or fixing bugs in. And a lot of our time was being spent on that upstream task of understanding what's going on in the code base. And so to address a lot of the pains that we had around understanding code, we built this thing called Sourcegraph. Sourcegraph is a tool that's optimized for reading and understanding and grokking source code. So a couple of the key components of what we built, there's a search interface, so you can search for symbol names and regular expressions, quickly locate pieces of code across the open source universe or inside your company that might be relevant to what you're trying to build. And then there's kind of a code navigation interface. So the idea is that we want to make jump to definition and find references just table stakes over any sort of repository in the world. So you don't have to set up a development environment. You don't have to like build the project. You just get the ability to walk the graph of code seamlessly. And over the years, we've been working on this for a while, so we've made it work for a lot of different languages and open source communities. We've been fortunate enough to land some great customers as well along the way. So Sourcegraph today, or I should say Sourcegraph as of a year ago, was a fantastic tool for human developers to go and make sense of large corpuses of code. And it was about a year ago that we started playing around with more AI and machine learning informed techniques. This was right around the point in time where GitHub released Copilot and GPT-3 came out, and we started seeing signs that a lot of this could be used in the context of searching and understanding very big code bases. And so our first foray into the realm of machine learning in the context of code search was trying to take some of the large language models in existence at that time, taking the embeddings representation out of them and using that as kind of a signal to relevancy in code search. So by now, like this is kind of a common practice. Like every single vector database in the world now basically uses this approach: take the embeddings out, do nearest neighbor search, and use that as a signal when you're searching over things. But that's where we started as well. And a lot of the things that we learned in doing that, building this early prototype called CodeSearch.ai, now informs how we're developing Cody, our AI coding assistant. And so all that is relevant because those are all pieces of signal and context that feed into Cody. So I just want to So what I have open here is this is just vanilla VS Code, but with the Cody extension installed. And what I've done is clone down a project, Langchain. How many people here have heard of Langchain? Okay, almost all of you. Anyone not heard of Langchain? Okay, so suppose I was living under a rock for the past, 3-4 months, and I hadn't heard of Langchain. And coming to this as a new developer unfamiliar with this code base, one of the first questions I might ask is like, WTF is Langchain? And so what Cody will do is actually do a couple code searches across this repository and read some files and explain to me what Langchain is. And this is kind of noteworthy because if you pasted this into ChatGPT would say, like, I'm sorry, my training data ends in 2021. There's nothing called Langchain out there, and therefore I can't answer your question. But what we're doing with Cody is actually having the language model, quote unquote, read the files that are relevant. Again, using the power of code search and the code graph and some of the AI-informed signals, we can actually surface relevant source code files and documentation that are helpful in answering user questions. So we're feeding these files into the language model, and on the basis of that, Cody's able to answer what this project does at a high level. And from there, I can kind of drill down into the functionality. So, a popular thing I've seen on Twitter is like people are turning PDFs into chatbots. So, let's say I wanted to make the latest and greatest like PDF chatbot using Langchain, because like that's what this library is for. I could ask, one thing I can ask is, does Langchain support fetching data from PDFs? And Cody will search for the relevant files, surface them using Sourcegraph APIs. It reads through a bunch of files related to various things and says, yes, Langchain supports loading data from PDFs in several ways, and actually gives me some symbol names, which I can verify exist. So this is like an actual symbol in the library that I can use. And let's say I want to go one step further and actually contribute to this project. So I'm onboarding this code base. I want to make a contribution. I can ask, which are the files that handle PDFs in Langchain? Every chat message, my heart kind of skips a beat, hoping that nothing's going to break. So it points me at a couple symbols, a couple files here. Actually open this one. We do some basic verification in the output to verify, these files actually exist, because as we all know, language models have a tendency to lie confidently. So we're kind of fact checking the output. My paste isn't working, so I'll just type that out. Here's the file. Sure enough, it handles dealing with PDFs. If I want to dive into this, I could open up kind of like an inline chat window. I can ask, like, explain what this class does. If I'm too lazy to read through the source code myself, turn my brain off for a little bit, let the AI do all the work. It tells me, okay, here's what the class does. It's also reading related files, so not just this file. It pulls in more context of the code graph. And if I wanted to modify a file, or sorry, a piece of the code too, let's say I wanted to enhance the documentation in this code base, I can use this like prefix fix. I could say, like, make the docs and comments more detailed. And so the basic idea is that we're playing with both, the Sourcegraph APIs, the code graph, context for the code, and then combining that with language models to produce things that we think will be useful for making you productive in the code base. I saw a question go up.
I have a question. So how do you read the file? Like, do you pass it in as tokens, or because I would love to figure out how you select the most snippet and how to explain.
Yep, I will get to that in 90 seconds. So the next slide. So here it augmented the comments with additional context that it gleaned from the source code. We also have these things called recipes. They're kind of like templated interactions. So you can explain code at a high level, generate doc strings, translate stuff to different languages, generate release notes. That's popular. Read through your Git history and generate release notes for you. Essentially trying to automate a lot of the toil or tasks that we find toilsome in development, so that we as humans can focus on the fun parts of the job. coming up with new data structures, solving end user problems, and things like that. So that's the demo. Now let me go back over to my slides. Okay, so that's, nope. Okay. All right, so how does all that work? Well, here's how it works. So the basic thing that we rely on is some large language models have quote unquote like reasoning ability, like a semblance of reasoning. I wouldn't go as far as say it's actual logic or critical thinking abilities. Stop short of saying it's like glimmers of AGI, but like they are good at pattern matching. And so if you give it a question that contains multiple pieces, it can attend to different parts of the question and synthesize the parts of that question into an answer that's accurate. So there's lots of cases of it solving like word problems by breaking a problem down and attending to different parts of the question. And so it's that general principle that we apply in the context of code. So the idea is that when we're issuing an API request to the large language model, we're essentially placing relevant facts into the context window so that the language model can attend to those when answering the user question. So just to cover like a really simple example, let's say the user request was, what storage backends does this library support? Well, then if we can fetch a code snippet that looks like this, which is like a function that ostensibly uploads a document to Google Cloud Storage, we'll place that in the context window, and then the language model can attend to that snippet to generate a clear, factual, coherent answer. So that's all there is to it, really. And a lot of it comes down to, like, can we locate that function, which is like the magical thing that provides the right answer. And so one way to think about this is, how many people are familiar with like the Chomsky versus Norvig debate in AI? Like whether the approach to true artificial intelligence is going to be through these like, we thought really hard about the structure of grammar and have mapped out the entire, grammar of language versus like the more statistical or machine learning driven technique of like, we don't know anything. We just made a model and dumped lots of like data into it and then learned the right things. We're actually thinking not in terms of like either or. We actually think they're very highly complementary because the things that the language models aren't good enough, which is factual accuracy and precision, we can actually provide with techniques that are informed by compiler based retrieval and classical code search. And so to answer the earlier question of like, how do we actually go and allow the language models to read these snippets? What sort of things do we do to fetch exactly the right snippets? On every user request, what happens is we'll look up context using the Sourcegraph code graph, surfacing relevant source code snippets and pieces of documentation. We then pass those as context to the large language model. The nice part of this architecture is we can be relatively agnostic to the language model that we use. So currently we default to Anthropic. Claude is a really good model. We love those guys a lot. They've been really helpful in kind of being partners and building this. But we can also support OpenAI, and some of the newer open source models are also quite interesting. And there's a little bit of prompt engineering that we have to do to integrate a new language model, but since the interface is natural language, these are mostly just like swappable. So we pass the context to the language model, get the response back, and then we do have to do some post-processing on it because sometimes they still lie, even given context, or maybe the context we fetched isn't that great, and so they made up an answer. And so we have some basic guardrails in place to flag things like hallucinated file names and symbol names and things like that. And then the final step is to synthesize all those signals together and like return the response to the end user. And so all that happens on every single kind of chat message or auto-completion that happens in Cody. Okay, so that's the basic architecture of the system. Hopefully I've given you an idea of like how it works at a high level. Now I want to share some of the challenges that we've had, and maybe this will be useful for folks who are working at the intersection of AI and developer tools. Okay, so here's a failure case. A lot of times when we share Cody for the first time, people are like, okay, I'm gonna give it a softball question. What's an easy question? Well, an easy question is like, how many TypeScript files are there? That should be easy, right? Like a human can answer that pretty quickly. But Cody cannot. Now, why is that? Number one, like language models kind of suck at counting. And so like even if you give it like a bullet point list and ask to GPT-4 to count the number of items, like it's not 100% precisely correct. But the real reason here is that this is kind of like a survey or like an aggregate question. So even if I fed like every single file name into the context window, then the model would have to go and like count how many there are. That's not a good way to solve this problem. The way I would solve this problem as a human is I'd probably just like execute a find command and pipe it to wc-l or something like that. And so one of the things we need to do is enable Cody to make better use of tools that you might use as a human to answer these questions. Another problem continues to be hallucinations. So the context fetching and the guardrails do help with this. Here we're flagging that the file that it made up in its response doesn't actually exist. That's the yellow highlighting. Highlights as green if it does actually exist, but it's still a problem. And this is something that we're actively working on by improving the context quality, as well as adding better guardrails. Another failure mode is when your user question requires information that's actually outside the code base. So we do a good job of fetching potential snippets within your source code, but let's say you're staring at something in your issue tracker, and you're like, okay, what file should I look at if I want to get started on this issue? Well, Cody doesn't know about your issue tracker, but it will pretend that it does, and it will kind of like make up an issue description and confidently tell you that like these are the files that you should attend to. And I think the solution here is, again, to expand the context that Cody has access to. So the direction we're thinking is like, maybe Cody shouldn't just know about your source code. Maybe we'll give it access to the API that fetches content from the issue tracker as well. And then another problem is sometimes people want to ask questions where the answer involves looking through the Git history. So it's like coming back from vacation, you're like, hey, what changed in the code base in the last week or so? Or you're working with someone, you're trying to figure out like if they're the right person to ask about a particular code, you might ask, have they changed this piece of code recently? And Cody doesn't know how to invoke Git natively. Now we have added a recipe to Cody where you click a button and it will read through your Git history and generate like a summary of the past day or week or month of development. That's also how like it generates release notes. But these are pretty like guided, templated interactions between the language model and Git so far. Now there's one common theme that's running through all these failure modes that we've noticed. And it's basically that whether Cody is good at completing a user request or not comes down to the context that we feed it. In cases where the context is really good, where you as a human could take a look at the context and come up with the answer, generally Cody gets the right answer. Like it's pretty good at synthesizing those pieces of context into something that's accurate when the context does contain the facts necessary to make the answer. But in cases where the context is garbage or just not accessible to Cody, then it will just make stuff up. That's what language models do. They're trained to be kind of like nice and compliant and to try to like please your request. And that often means that instead of saying like, I don't know how to do that, or like, here's what you need to do to help me get to the right answer, they'll just make something up. And so one thing that we started saying around kind of the halls of Sourcegraph is context is king. Like all of our challenges come down to context quality. And when context is good, that's when we get these sort of like magical interactions. So here is an example on Langchain. It's like, how can I create a simple chatbot with Langchain that reads from a corpus of PDFs? And this is not 100% accurate, but it basically gets you like 80 or 90% of the way there to understanding the steps you have to do to create a simple chatbot using the Langchain APIs. And again, here it's reading, just look at the files I read, right? Like these are the right files to read. It's like getting started tutorials, a bunch of examples in IPython notebook. Another example, so Cody, its source code itself is open source under Apache 2. So you can actually go and add stuff to Cody. I was trying to add a recipe to Cody the other day, and I was asking Cody how to add the recipe to Cody. And Cody basically told me every single file that I needed to modify to add a new recipe. And it was actually this magical experience where it probably would have taken me like several hours to go and figure out what the right files to edit would have been. But because I could just quickly get to all the pieces that I needed to change quickly, it took me about 30 minutes. And again, here, it fetched really good context, which is why it was able to come up with a good answer. And then the last example is, when you're learning a new library. So like there's a new front-end JavaScript framework called Quick, kind of trying to like replace React as I guess like the king of front-end frameworks. I met the creator, and he convinced me that was the future. So I was like, oh, I'll play around with this last weekend. And it actually helped me, Cody helped me learn the kind of general shape of the APIs very quickly, because I'm a React developer by background, and so a lot of the things I was trying to do were still like React based. And so I was actually asking, could I use a React function component in the context of this library? And it's like, yes, you can, but here you need to invoke this like Quickify $sign function. And that was exactly the thing that I wanted. So what do we do with these takeaways? Well, our conclusion is that the future of Cody is we want to integrate all the context. So, first of all, we're going to build clients for every major editor, but on the back end, basically like any system that could contain a piece of context or facts or a piece of information that are relevant to you getting your job done as a developer, we want to integrate into Cody as a context provider. And I think this feeds into our decision to open source it, because we think by being open source, we can be truly kind of tech stack and platform agnostic way of integrating all these pieces of context into one sort of system. So whether you use GitHub or GitLab or Bitbucket as your code host, whatever, like your tech stack, we want to make it able to use Git as a context provider. There's obviously the context that Sourcegraph provides. We're actually building an integration for Confluence right now for a customer of ours, because there's a lot of technical knowledge buried in wikis. And we also started exploring at integrating some production logging systems like Honeycomb, because that's also relevant for getting your job done. And so here's our open strategy. I'm going to be a little provocative here. Do we have any GitHub people in the audience? All right. Tom, Preston, Werner. Hey, Tom. So there's already been a couple of early users of GitHub Copilot and Copilot X that have pasted in the GitHub issue tracker, basically pointing at Cody as, hey, you guys should be doing this at GitHub, because the context fetching is way better and actually pretty essential for making a chat-based interaction work. And we think that the reason that we've been kind of able to pull ahead here, and I would say this is also kind of interesting because we don't even do the thing that Copilot excels at right now, which is kind of line-by-line auto-completion. That's not yet a feature that we've shipped. We're working on it, but the fact that people are doing this head-to-head comparison strikes us as a little bit interesting. For the record, you can use both side by side today. So if you're already a happy Copilot user, I think it's a great product. You can also download and use Cody alongside it. But it's interesting that people call this out, and I think this will allow us to move more quickly too, because we're not going to be tied to kind of a proprietary platform. We're not going to be tied to a single foundation model provider. We can allow our users to have kind of freedom of choice when it comes to their other tools. We love contributions. We have a community Discord. In the latest release, someone actually shipped a new recipe that optimizes code in Cody. And another thing that we like about being open is that something just feels right about it, building a developer tool, especially when you consider, there's this question of how do large language models work? Where do they get this kind of quote unquote reasoning ability from? And there's actually a growing body of research that suggests that the reasoning ability arises not so much from RLHF, which is getting all the hype and attention, but actually arises from training on large amounts of open source code. And so in a sense, the logical abilities of these AIs is really just the product of all the knowledge that's kind of buried in the open source universe. And so it feels good to us to kind of contribute back a tool that's built on top of those capabilities. And here's a link to the paper or a blog post that points to that evidence. And then the last thing I want to say about what's been really cool about working with language models in the context of developer tools is, so our mission at Sourcegraph is to make it so that everyone can code. And it's actually caused a lot of people to scratch their heads over the years, because today we're mainly an enterprise SaaS company that makes a product for professional software developers. So it's how do you draw the line between that to now everyone can code? Well, I think language models actually bring forward the horizon of being able to achieve that mission, probably by a decade or so. And this is a piece of feedback that was actually sent to us by one of our users in South Africa. This was someone who had kind of lost their job at the beginning of COVID because all the pandemic era lockdowns. And he basically tried Cody and sent us his email a couple weeks after trying it. And I'm just going to read it because I think it's just kind of amazing. He said, I tried everything claiming to aid learning to code, and I've used multiple AI extensions and packages in an effort to find something to both ease me into coding and accelerate my learning. the buzzwords and fun tech is one thing. The structure and implementation and application of these concepts is what's important. And you got that recipe just right. Blah, 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 a lot of praise. Your product in 2 weeks took me from not understanding coding logic at all to writing, running, and debugging scripts and small modular programs in both Python and Shell script. From doubting my ability to learn to code to basic understanding in 2 languages. So that's really cool. It really speaks to like the power of combining both, classical compiler-based techniques, the graph of code, with large language models, and the possibilities that open up when you give this to everyone in the world. So thanks for coming to my talk. If you want to try out Cody, it's available today as a VS Code extension. There's also a version in the web that you can try out. It's a little bit jank right now. I do apologize. You have to sign in via GitHub or GitLab, and then there's like an Ask Cody button that appears on the side there if you want to try it on the web. So we have a lot of work to do to smooth out like UX rough edges, but if you want to try it out, we'd love to hear your feedback.
So I saw you did a slash command to invoke something.
Yep.
I'm curious if you have any ideas for specific grammar, because when you did WTF Langchain,
Yeah.
I was like, is that a specific grammar to Sourcegraph?
No, WTF is WTF is not Sourcegraph specific syntax. We thought a bit about this. I think we're probably going to copy like the Slack thing, which is like slash and then the name of the command for starters. And then I don't know, you could see it evolving over time. So like one of the ideas is like the code, the generate unit test recipe. Sometimes it's helpful to like point it at a specific unit test that you want to copy in order to generate a good unit test. And so we thought about maybe like templatizing that, adding a little bit more grammar syntax around it so that you can actually like feed a slash command, maybe like an argument or something that's relevant.
Demo for the group, the talk. Can you give us some foresight and ideas that you are toying around with about how the editor experience may change in the future, like how it will evolve? Because right now it's a traditional editor experience plus the assistant that helps me highlight stuff and get questions answered.
Yep.
But I wonder like what abstraction I will be with all of this. So I'm sure you're discussing this quite a lot and have talked about this.
Yeah, that's a great question. Like, how will the in-editor experience change if a lot of the code is generated perhaps through like natural language prompting? I do think that's a really interesting avenue to explore, and I think where our mind goes is to start with that kind of like inline chat mode where you use like a piece of code and ask it to make a change. That feels like a natural jumping off point for us, because then you can be very intentional about what section of code you want to change and very precise in your instruction. The tests that we've done so far that are more like general, like, hey, Cody in chat, just take advantage of the contents of my code base and make an edit. The issue right now is like, when something is 80 or 90% reliable, it's fine for just kind of like a one-off, like, I'm going to ask you a question and I'm going to fact check your answer. But if you try to inject that thing into like a larger component that's executing in the background hidden from the end user, it is not inspectable, then every step that you add that's like 80 or 90% reliable kind of reduces the overall reliability exponentially. So if you have a couple of those steps, now it's like a coin toss whether it works or not. And so far, we've not been able to get to a good user experience that's just like completely generic, like can you type something and have it automatically do the right thing. I know there's like a lot of demos, I think, on Twitter where it's like, oh my gosh, like I generated a complete code base just from prompting. But when we've actually played around with it, you can do that for like kind of like a simple application that you built. But when you're working in the context of a large existing code base, you very quickly run into the intellectual limits of large language models. That's it.
Amazing. Do we have any more questions? Okay, just one more.
So how does Cody scale with large possibilities? Yeah, so that's a great question. How does Cody scale with large repositories? So our existing customers have very large mono-repos, so we're making it work in that setting right now. I wouldn't say there have been no scaling challenges. It's mainly about, I think currently the limiting factor is making the kind of like vector-based nearest neighbor embedding search scale, and we've been looking at the vector databases that you've probably heard of, as well as like open source libraries that we might use to build our own system to do that.
Great. Round of applause.
Okay, so